Welcome back. In this video, we will try to understand why there was a need to build a concurrency in Go programming language. To understand that, first we need to understand the operating system, processes and thread. Operating system, the idea of concurrency comes from the operating system. The job of operating system is to give a fair chance to all the processes to run. Most of the time it gives equal opportunity to all the processes, and there are times when the higher priority task can take the precedence. The idea of concurrency starts with the process and threads. When it comes to the Go, we shall see how Go implement the concurrency. Let's talk about the process. Process is an instance of running program. A process gives an environment for a program to execute. When a program is executed, operating system creates a process and allocate a memory in virtual address space. Virtual address space contains code segment, data segment, heap and stack. So code segment holds the compiled machine code, whereas data region contains the global variable. Heap holds dynamic memory allocation, and stack is used for storing the local variable of a function. Let's talk about the thread. Threads are the smallest unit of execution that a CPU accepts. Each process has at least one thread, that is main thread. The process can have a multiple thread, and thread shares the same address space as a parent. So thread can run independent of each other. The operating system scheduler makes the scheduling decision at the thread level, not at the process level. The threads can run concurrently, with each thread taking turn on individual code, and they can run in a parallel, with each thread running at the same time on different codes. So there are four different states: runnable, executing, preempting and waiting. Let's understand thread state. When the process is created, main thread is put into the ready state. It is in the runnable state. Once the CPU is available, the threads start to execute, and each thread is given a time slice. If that time slice is over, then thread gets preempted and placed back into the queue. If the thread gets blocked due to the IO operation, or like read and write operations on the disks, or the network operations, or maybe waiting for some other event to happen, in such situation that thread is placed into waiting queue until the particular operation is completed. Once the operation is complete, it is placed back into the ready queue. Now you may ask, can we divide our application into processes and threads and achieve concurrency? Yes, we can, but there are limitations.